Let's have a look at question C. So they ask, can you use the confidence interval from part A in this test? Now, before answering, let's actually draw the part A. So the confidence interval that we found a confidence interval of 95%. And then we also draw the test that we applied, and we'll see if the answer is yes or no. So if we draw this on a distribution, what does it mean? Confidence interval of 95%. It means that we allow for a type 1 error of 5%, which means we will have 2.5% on each tail. So we would have here 2.5%, and we would have on this tail 2.5%. And in the middle, we're left with our confidence interval of 95%. Now, what was the test? The test had the hypothesis whether the expenses on housing is 650 or less than 650. And we said that because it is a one-sided test, we want a significance level of 5% only on one side. So let me draw that with a different color on the distribution. We want 5% on one side, meaning that under the test that we have, we must have a tail of 5% here. I'm not going to shade over it because I want to keep both to be visible. So here we want to have in total 5%. And here on this side we also have 5% because it's a symmetric distribution. The t distribution is a symmetric distribution. So here we also have a 5%. And now this thing over here, the remaining, is our 90% confidence interval under the test. So we're left with a 90% confidence interval. And now look, intuitively we can see that we're dealing with two confidence intervals. When we're dealing with two confidence intervals, we cannot use both to give the same conclusion. And why is that the case? Let's prove it. So suppose we're here. Suppose our test is the following. Mu is less than 650 under the null hypothesis. For that, we construct a 90% confidence interval, because that's what we said. A 5% significance level, a 5% alpha on one tail means a 90% confidence interval in the middle. Now, if we had a value, let's say if we had a value which was over here, we had a value, let me draw it. So from here we have the 2.5%. This is the 2.5% tail, and our t value would be in between this range. Well, according to the 90% confidence interval, which is our test, we would reject the hypothesis. We would reject H0 because the critical value under our hypothesis would be at this green line over here. That would be our t critical value. And if we're to the left of it, we're in the rejection region under our test. But if we were to use the confidence interval from part A with a 2.5%, let me get a different color. So if we were to use this one, the 2.5%, which is the rejection region from the purple line to the left over here, well, look, in that case, if we are in this region, if our t value is over here, which I showed with the arrow, we are not in the rejection region. We are not in this yellow line. So according to the 95% confidence interval, that we used in part A, we would not reject the null hypothesis. So same value, but based on two different confidence intervals, we give different conclusions, and in that case we would be wrong. Do not reject H0. So we would have, a rejection region. We should say that our observation is significantly lower based on the test that we're doing, but if we're using the wrong confidence interval, we would give the wrong conclusion. So the answer is no. We are done.